But yeah, we can jump right in, and thank you all for coming to this talk. Can you please raise your hand if you've heard of the term data observability before? Oh, wow, okay, all right, we can get right into the meat of things. Well, this talk, the title has a little bit of a lie. I'll explain that in just a second. We're trying to walk through the historical context, the present moment, and some future ideas around data observability. And the goal is that you can all leave with a firm grasp of what exactly does this marketing term mean, and more importantly, how you can think about applying it within your organizations. But I'm Kevin Hu. I'm sorry, I came here wanting to get a trench coat and a bow tie, but unfortunately all of the Doctor Who jokes will have to wait. And I am the Chief SQL Wrangler at Metaplane. It is neither meta nor plane, it's actually just Metaplane. And if anyone has any questions, please let me, okay, never mind about that. You can definitely, send me an email afterwards. But 4 things we're gonna talk about today. 1, the history of data and observability and of data observability. 2, what the heck is this? 3, unfortunately, we won't be able to demo, but I'll point out where our booth is in case you're interested. And finally, how do you put data observability into practice? Let's talk to the history for a second. And the reason I lied is that this presentation doesn't actually start in 1788. It starts around 3400 BC. And what we're looking at is an ancient tablet from Mesopotamia or Sumeria at the time, and it says a total of 29,000 and something measures of barley were received over the course of 37 months. Signed, Kushim. Not only was this the first moment at which we had a person's signature engraved onto something that's extant to today, but it's the first Salesforce transaction of all time. You could argue that it wasn't as good as Salesforce, but I would argue that they had autosave, so it's actually not so bad. And the reason I started there is because if you go back in time, you would expect, or at least I expected, that some of the oldest pieces of writing are pieces of wisdom that we have from our ancestors, right? Stories, laws. But no, some of the original pieces of writing were actually just pieces of data, in this case, transactional data. Or in other cases, customer service complaints. And this is the first Zendesk ticket filed. When you came, you said, I will give you fine quality copper ingots, but then you left and did not do what you promised me. And clearly there's much more to that complaint, as there typically is, than we just translated. But today we use Zendesk for that. And as another cute example, we also have one of the first data quality issues, or one of the first data quality misunderstandings, right? I wrote that you had to send over pots. Instead, you sent straw. Apparently, I don't know any speakers of cuneiform or any people who can read cuneiform, but pots and straw are very similar in some regards. So this was one of the first misunderstandings when it comes to data. And why do I start there? I start there because where we are today is unique in many ways. Look around us, right? It's an incredible time to be alive. But when it comes to data, we really are drawing on a very deep and very rich discipline. Going back to 4000 BC and progressing through various analog forms of storing information. I believe going down to books and then going down to punch cards. And finally a shift happened around 50 years ago with the invention, thank you, Papa Edgar Codd from IBM for creating both the relational algebra and the first architecture for the first relational data stores, and the idea of modeling data in a tabular format and having well-defined operations on top of this tabular data. And where we live today is really a continuation of that moment in time in which we're no longer tethered to this idea that data is one-to-one with a physical inscription, but rather we have digital information that captures the information that we want to know about the real world. And if anyone remembers, Oracle came out, IBM DB2, these are the mainframes that the whole world actually still runs on. Is the whole joke that the world's financial system runs on, one person with a gray beard running COBOL. Well, what database are they using? Probably Oracle. But things have progressed into the 90s and the 2000s with the advent of columnar data stores with Vertica, and finally to the past decade in which around the early part of the 2010s, we had Redshift and BigQuery and Snowflake. If anyone here remembers the big data era of Hadoop, I wrote a lot of Hive jobs back in the day. Thankfully, it's been a couple of years. And this is the world in which we're living in today. And there's many vendors who are taking that even one step further. But like, what is new, right? There's a whole story about how history doesn't repeat, but it does rhyme. And I would argue that what we're seeing today is a matter of degree and a matter of complexity, where if we look at the data stories in the middle, business intelligence, or more broadly decision support, will always be the main vein of data throughout organizations. Some of the first software applications were decision support. One of the biggest use cases of data today is decision support. However, what we're seeing is a much wider set of use cases for data, whether it's machine learning and artificial intelligence. I'm just going to call it stats so we don't have to go into that whole debate. We have operationalization of data by sending data from a database into tools like Salesforce and Marketo and Zendesk. We have companies that are using data to enhance their product experiences with in-product analytics. And the list goes on. And furthermore, as the destinations increase over time, the sources are increasing over time. If you're working a data team today, how many sources do you have, right? A crazy amount. Third-party sources, internal transactional data, event streams, SaaS applications. So this degree of complexity, I would argue, is unprecedented, especially with the amount of companies today that are bringing on modern data stacks. And that's great, right? Like, we're data professionals. We want to see data more widely used and, more importantly, tethered to the most important metrics of a company, right? Because what do companies do? They increase revenue, they mitigate risks, and they reduce costs. How do they do that? They do that by taking a sequence of intelligent decisions and executing on those. And ideally, data can help inform those decisions and make your actions more effective or more automated. And all of our use cases are in the service of informing those decisions and taking those actions, which is amazing. And it's amazing that we have more data usage. However, you also have more surface area to maintain, right? It's a double-edged sword, right? You probably have hundreds, if not thousands, or tens of thousands of tables and dashboards and syncs that the data team is responsible for. But the VP of marketing only cares about one dashboard, which is the one that they're currently looking at. And furthermore, the business stakeholders are the ones with the most domain expertise, as they should be, so that when a number looks weird and it's like, oh, it goes down a little bit, guess who's getting a Slack message? Your teams. So as you have more breakage, that leads to lost trust. Every time you get one of these Slack messages, you're taking a little coin from trust, and that's very easy to lose and hard to regain. Which leads me to EDT, the great product announcement, which is the most popular, open source, and free form of data testing. And it's executive-driven testing. It's the head of marketing or the VP of sales being the person to Slack you, hey, why does this number look weird? And unfortunately, this is how most teams today find out about data quality issues. So the question is, can we learn from other industries that might be more mature in certain ways? And this is, one parent of this presentation where in software engineering, there's a very robust set of software and DevOps observability tools. You think of Datadog, Splunk, Sumo Logic, Dynatrace, in which you build entire applications on top of the three pillars of information: metrics, traces, and logs. And in theory, these three pillars of information are the necessary and sufficient information that you need to reconstruct the state of your software to arbitrary resolution at any point in time. Of course, some is lost, but in principle, that's what these software observabilities do for software teams and their infrastructure. But if we go back in time a little bit further, the person that you're looking at on the left is Christian Huygens. He was a contemporary of Isaac Newton. I don't believe they liked each other very much, and I don't know how they got that just from letters. But in addition to being the discoverer of Saturn's rings, he also invented the centrifugal governor. And the centrifugal governor was invented in order to control the milling speed of windmills. So Christian Huygens was a Dutchman. They have a lot of windmills back then. They still have some today. And the problem is that wind blows at variable speeds, but you want to mill grain at constant speeds. So the idea behind a centrifugal governor is that you have a little bit of regulation. You're almost like an ice skater where when you put your arms out, you slow down. When you bring them in, you speed up a little bit. And down there, you're actually looking at a picture of the Brixton windmill, which is where I'm staying in London, super interesting place. And they have a centrifugal governor that you can visit, whatever you want. And the reason I bring that up is because in the late 1800s, James Clerk Maxwell, famous for Maxwell's equations of electrodynamics, of electromagnetism, looked at the centrifugal governor and said, hey, wait a second, how the heck do you model this system in exact terms? And, as a side project, because, apparently he didn't have enough to do, he invented what we now call control theory. And control theory has many applications across electronics, even economics and sociology. And the principle is, given a complex dynamic system, how can we understand the output of the system and the state of the system given the inputs? And now you can see the connection, where there are two main concepts in control theory. One is controllability, right? Given the state of the centrifugal governor going in and out, how can we control the state of that system given the inputs? And the mathematical dual to that, in formal terms, but really the corresponding concept, is observability, is given what we observe about a system, externally, how can we infer the internal state of a system? This is why observability was co-opted into software observability as a concept, because these metrics, traces, and logs are really breadcrumbs left behind by our infrastructure that we use to infer the internal state of our software infrastructure at any point in time. And a little bit later on, we're going to be doing that for data as well. So the problem is data entropy, right? More data usage, more data breakage, entropy tends to increase, thermodynamics, it's really brutal to get around. And the solution, the inspiration rather, is visibility through observability. Leads to data observability, question mark? And what is data observability? Well, I'll start with what data observability is not. As much as we try and market this term, we being all the vendors in this space, data observability is not a problem. Data quality is a problem, right? Data practitioners and data leaders wake up in the morning like, oh my God, we have a data quality issue. I need to solve my data quality problems. No one, as far as I know, wakes up saying, I really need a data observability tool. If you do, please send me an email. I'm very happy to talk. And data observability, as far as we conceive of it, is a technology that's used to solve a broad set of problems, including data quality, which we define as the degree to which data satisfies an external use case or internal standard. Because remember that data is ultimately meant to be used, right? The use cases of data directly impact the top and bottom line and risk of a business. So if data does not meet that use case, there is a data quality issue to some degree. Data observability is the degree of visibility we have into the state of your data at any point in time. Similar definition as software observability, right? How much visibility do we have into the state of our data infrastructure today, right? If we go out for a beer and I ask, like, how many liquor dashboards are being used right now? When was the last time all of your tables were updated? What is the downstream lineage of this specific Snowflake table? And it's possible to get that information. All of that metadata exists. It's just kind of flying off into the ether currently, which is not fantastic. And the way we think about the 4 pillars of data observability is, what is the necessary and sufficient information needed to reconstruct the state of our data system? And we draw a couple of inspirations from physics here, where take a look at this water bottle, right? There are some intrinsic characteristics, like the temperature of this water bottle, right? If I double the volume, if I get a really big jug of water, it could still be the same temperature. And that's an intrinsic characteristic, where our data also has intrinsic characteristics. Given a column, what is the distribution of that column? What's the number of enums that you have? Does it contain PII? That doesn't really depend on the number of rows, but there are extrinsic characteristics. Like if I double the amount of water in here, the volume doubles, right? We call that metadata, the external characteristics, the freshness, the volume, and the schema, everything that you kind of see from the outside of the data. And as we know, data doesn't exist in a silo. It's not just one table in your Snowflake table. There's many tables in your Snowflake instance, and they're deeply interconnected because as much as Snowflake says that it's a source of truth, it doesn't generate information, right? Data is either put in by a human or put in by a machine that was told by a human to put that in. And there's a large DAG of lineage from there. So the lineage encodes the dependencies between data, both upstream and downstream, and the logs contain the external interactions between data in the real world. How often is this table being accessed by a Looker dashboard? How often is this Looker dashboard being used by the VP of sales and so on? And with these 4 pieces of information, we can go back and answer basically every question that we have about the state of our data at any point in time. But before that, I want to say congratulations to you all on the new role. You are now the head of data at Wordle Industries, in an alternate universe in which Wordle was not acquired by the New York Times, but instead got $200 million of funding from Tiger Global to expand global expansion into 6-letter Wordle, 4-letter Wordle, Chinese Wordle. I don't know how that would work. And now you get to build business value. And welcome to your data stack as well, where you have Postgres, Snowflake, Segment, all piping data through Fivetran or Airbyte or an ELT tool into Snowflake. You're using dbt to transform the source tables into staging tables and analytics-ready prod tables. And those analytics-ready prod tables are being used in Looker, used by the growth and exec team, and used by Salesforce, used by the sales team. And there's a whole taxonomy of data quality issues. Right, I believe Tolstoy said in Anna Karenina that all clean data is the same, all messy data is messy in its own way. I'm pretty sure that Tolstoy said that. And there is, a finite set of categories of data quality causes, ranging all the way from very explicit exact input errors to incorrect transformations to different individuals having different concepts of what information means in their head, just like the person with the pot and the straw 5,000 years ago. But regardless of the cause of a data quality issue, one of the main use cases of data observability is incident monitoring. So let's move past EDT for a second and say that if we have the metrics and metadata, right, the internal and external properties of data for this 30-day usage table that you see highlighted, could we potentially pull in the schema of this table, pull in the number of rows, maybe pull in some aggregate summary statistics about the columns, and then apply anomaly detection over time that takes trends and seasonality into account? Well, once we do that, then we're able to say, okay, here is an anomaly in this specific table. It's far below expectation, and you should probably do something about it. And the first thing that a data team might do is say, is this a real problem? And the second question that a data team might ask after establishing that it is a real problem is, okay, does this even matter? You're all busy people, right? If no one is using this table or no one is using this dashboard, perhaps it's not really worthy of your time at this given moment. And that is solved by impact analysis, which given the lineage, which are the downstream dependencies, and given the logs, which provide the time correlation of various changes in your data stack, can we identify that this 30-day usage table is actually being used in this Looker dashboard, in this Salesforce table, and by the exec and sales teams. And finally, once you say, okay, this is a real problem and it has a meaningful impact, the third step is, what is the root cause? Or can we do anything about this right now? And we can use those same 2 pillars of lineage and logs, saying, okay, the usage and tracking and identify tables within Snowflake are upstream of my 30-day usage table, that 2 of these are coming from segment events. And furthermore, that dbt and segment have had recent PRs. So those are good potential root causes, or at least a good way to get started diagnosing the problem. So those are 3 primary use cases for data observability. There are many others like spend monitoring and ensuring PII and security, but those are 3 of the big ones that at least our customers think a lot about. finally, the third part of the talk. Is everyone doing good? Oh, okay, perfect. Is the speed okay? All right, great. Is how do we put data observability into practice? Well, the first thing is like, what is the goal? And when we think about data, we always try and start from the goal in mind. I mean, I'm not trying to poo-poo on Crystal Palace. I've just been told that they're not the best team in the league, and I just wanted to put some team on there. I figure if I put Man City, some people would throw a tomato at me. And there's 5 main goals that our customers have when employing data observability. And in order of increasing abstraction, it ranges from saving engineering time, extremely concrete, right? My team spends 8 hours a week trying to identify and solve data quality issues. Can I drive that down to 4? Can I drive that down to 2? You can avoid the cost of data quality issues, which can be major, especially if it's used in a more automated setting. You can increase the leverage of your data team, which is critical as hiring data teams is very difficult, to put it lightly nowadays. So many teams use data observability both to bring on and onboard new employees, but also to make them more effective. You can expand data awareness throughout the company and within the data team. And finally, you can preserve trust. So I order it this way because preserving trust, I would argue, is probably the most important use case of data observability, but it's also the hardest to quantify. But let's say that you've identified saving engineering time and preserving trust as your 2 goals. Here are some examples of how to actually parameterize those goals. So saving engineering time, the number of data quality issues, very easy if you're using an issue tracker like Jira or Linear. Time to identification, time to resolution, these are very standard metrics from the site reliability engineering literature. When it comes to preserving trust, there are also explicit ways to measure how trust is being preserved. Well, it's a little bit messy, but you can have NPS scores, qualitative surveys that you have with the business stakeholders within the company, the number of inbound tickets if you allow data users to file inbound tickets, and if you really want to, put some muscle behind it, establishing an SLO or an SLA in agreement with those business stakeholders. So with those goals and with the metrics in mind, the next step is to identify who is responsible for implementing data observability. And one theoretical question that I wanted to ask you all is, why do doctors have bad handwriting? It's because doctors never have to read their own handwriting. Pharmacists do. And I don't know if that's true or not, but the point is that data producers and data consumers are ultimately the ones that generate data and consume data. And without an incentive to actually improve the quality of that data, it's always going to be garbage in and garbage out. And I don't believe that the data team should be responsible for all data quality issues, especially because the data team is not the cause of many of those issues, but ultimately they're the ones being held responsible by the business. So there's some incentives at play there. The most successful companies that we've seen, ranging from small startups to large enterprises, have a data business partnership to establish what are the main use cases of data, what is acceptable data quality here, and how can you contribute to that? And finally, with the goals and the people involved, the question is, how can we intentionally and repeatably direct our actions in a way that can be, actually drive our goals and not be one-off efforts? And this is where tools come in for data quality prevention. I don't believe all data quality issues can be prevented, but establishing data contracts, having data and code unit tests, active observability tools that are integrated into your CI/CD pipelines, passive observability tools such as Metaplane that pull in this sort of metadata over time, and then you have incident management playbooks also pulled from the SRE literature. And finally, how can tools help? Well, sometimes I do prefer using a stone tablet, but the good thing is that today we have better tools at our disposal, whether it's a combination of open source data observability tools, commercial tools, or building something in-house. There's pros and cons to each, which you probably all have assessed before, and data observability is not an exception to those pros and cons. But our thesis is that data observability is not the job of the data team, right? It's providing valuable data to the business to drive these use cases. So we don't believe that data observability should be an enormous initiative, right, that gets in the way of other work, right? Try it out, implement it within an afternoon, and then let it grow over time and then build some muscle around it. So one example of how this can be implemented, and this is actually pulled from one of our customers, is the goal of data observability is to preserve trust. And how they do that is quarterly NPS surveys and having SLOs established on the most important Looker dashboards, which they establish with their executive team. They have the head of data that has quarterly interviews with business stakeholders. They've implemented a response playbook, data unit tests, and passive data observability via Metaplane. And through this, they've seen pretty drastic improvements in data quality and data coverage over time. A quick plug for Metaplane. The last one is that it's the only automated end-to-end tool that you can implement. In less than 10 minutes, we have automated anomaly detection out of the box based on those 4 pillars of information. We have automated lineage both within the warehouse and between the warehouse and BI tools and upstream tools. And you can send alerts where your team already works. So a Slack alert might say, hey, this KPI has tanked far below expectation. Here are the downstream dashboards, the upstream dependencies, and the people that are involved. I'll skip the live demo because it's not working right now, but I'll point out where our booth is in a second. And the last thing I wanted to leave you all with is a little bit of a speculation about what data observability could look like in 2013. I mean, in 2032. I can tell you what it looked like in 2013. Okay, I will finally turn on the TARDIS for a second and say, okay, predicting the future is a fool's errand. If I could do it, we would all be a VC right now. But just applying a couple of concepts, like one is the Lindy principle, right? The best restaurants are the ones that have been around for 50 years, because if they weren't good, they would have gone out of business. And what are things that have been around for 50 years? Structured data, SQL, data teams, business intelligence. If I were to place a bet, these aren't going away anytime soon. That in 50 years, I don't believe, I see some skepticism from the audience. I would love to chat about that. But I would put my money on SQL. We can also follow Moore's law, and I would bet on this convergence of transactional and analytical tables. We already see a lot of database providers offering the combination of the two, streaming data as use cases become more real time, and ecosystem maturity, where if you think about it, almost all of the tools in a modern data stack are less than 10 years old. They might barely be 10 years old, and 10 years from now, the availability of metadata from these systems, in addition to the robustness of the systems themselves, will have much more information for observability tools. So my dream, personally, is that 10 years from now, the questions that we talked about today, like, are my dashboards up? Are my tables all fresh? Does this number look weird? That's going to be a thing of the past, right? That we can spend our time focused on the things that actually matter, and that eventually implementing a data observability tool will be as much of a no-brainer as implementing a tool like Datadog, where 10 years ago, implementing Datadog was a fight. But today, if you spin up a Kubernetes cluster and don't have some form of observability, what are you doing, right? And today, bringing on data observability is also a fight. But 10 years from now, right, bring on Snowflake, you should have data observability, right? Trust and the usage of data should come hand in hand. But to summarize, everything is old is new again, but with a vengeance. Data observability pulls from control theory as well as the research and data quality monitoring. The 4 pillars are the metrics, metadata, lineage, and logs, the internal and external properties and relationships. These pillars help address a whole slew of use cases, including incident monitoring, root cause analysis, and impact analysis. And the most effective implementations of data observability that we've seen start from a clear goal to back up what people should be involved, what processes these people should employ, and the tools that make those processes easier to repeat over time. But happy to answer any questions, probably not now because they're about to kick me out. And most importantly, if you have any, if you want to see a live demo over time, we are at booth 911. That was not intentional, but you can go to our booth for a free data therapy and a demo, and would love to see you there. Thanks everyone for your attention.